And in this session, next session, we have two public commenters. And again, remembering the ground rules of 5-minute presentation. So our first is Hugh Lambert.
Hello, my name is Hugh Lambert, nicknamed Skip. I am an engineer by education, University of Michigan, in the late 60s, and then became a lawyer. I worked for General Motors at Willow Run, Michigan for 7 years before becoming a lawyer, or before going to law school. And during that time, as a production process engineer, I was faced with frustrations having to do with my opinions for public safety, for worker safety, for environmental safety, being trumped by profit motives. And so after a few years of that frustration, I decided to go to law school, which I did. I clerked for a federal judge in Louisiana, New Orleans, for a couple of years, and then began working for individuals who, like me, had some frustrations and some experiences that were rather marginalizing. So I currently, along with several other law firms, represent people who live in Laplace, Louisiana. Laplace is a little neighborhood down the river from New Orleans, or upriver, really. And it is across and in the vicinity of the Dinka manufacturing plant, which used to be DuPont. And elastomeric products are manufactured there, and chloroprene and other chemicals, toluene, butadiene, all the enes, come from that manufacturing process. But we focused on chloroprene because that's the only place it comes from. So we don't have issues of confounding chemicals that could come from someplace else. And so what we've done is use an isoplat that was actually modeled by Dinka and DuPont. And inside of it, we did testing of urine of some of the residents that live inside of that isoplat. And sure enough, they have metabolites of chloroprene in their urine in significant concentrations, and obviously that comes from the exposure from the plant. The EPA got interested in it because of the concentrations of air modeling results done by the LDEQ, Louisiana Department of Environmental Quality, and EPA. And those air modeling results show not just a little bit more than 0.2 micrograms per cubic meter, which is the recommended limit, but hundreds of times over that value. At a public school in the 5th Ward, it's an elementary school, you're talking about 200 times the recommended limit, over and over again for years. The EPA, through the enforcement and compliance section, did some evaluations or inspections of the plant in October of 2016. And it disclosed tons of violations, non-reported, reported inaccurately, temperature readings taken not from the end point of the emissions, but from someplace in the process that made it look right. And the point being that those things can be fixed, and they're not. And they're not because the idea was to attack the ISIS results, the ISIS assessment that was done in 2010. I'm sorry, IRIS. You know, sometimes I get carried away. And I have to say that acronyms are always something that's a mystery. We get used to them. ISIS sounds more like, yeah. But anyway, the IRIS.
30 seconds to go.
Oh my. Do I get a penalty card just for? Anyway, the point is that assessment leads to the fact that based on science, those analyses need to be done so that there's no mistake in introducing policy into the issue before the actual science is done. And that's our point. In other words, don't let the policy arguments and the politics, particularly in this environment where there's so much decisive sort of politicization of government entities, all of them, as a matter of fact, but in particular the EPA, and do the analysis based on good science, and then let some other agency run by Nancy Beck.
Please wind up now.
I'll wrap it up. You know what I mean. Anyway, thank you very much. I appreciate your time.
And you got a bonus 30 seconds for ISIS. Let the record show.
Thank you. You know, one of my colleagues.
Oh, no, not falling for that. You're done. You are out of there.
Okay,
we're moving on.
Next,
Julie Goodman from Gradient. And thank you for your comments and your whatever.
There's no clicker up here. Thank you very much for the opportunity to speak today. I am Julie Goodman, an epidemiologist and toxicologist from Gradient, an environmental consulting firm, and I have received funding from the American Chemistry Council and other organizations to develop and evaluate systematic review processes. I have here a version of the schematic you saw earlier of the IRIS process. And I want to point out these colored arrows that represent human, animal, and mechanistic evidence. And as you can see, they're parallel. Each line of evidence is considered in parallel or independently until the evidence integration step. But instead, all lines of evidence should be considered together throughout the evaluation process, such that quality is appropriately considered and that each line of evidence informs the interpretation of others. And I'd like to spend the next few minutes talking about why this is critical. The first issue has to do with the relative quality of each line of evidence. And just as an example, oftentimes in pesticide research, the toxicology database is much more robust than the epidemiology database. So in these cases, the toxicology evidence should be considered more reliable and given more weight, considerably more weight in the analysis. But when lines of evidence are evaluated in parallel and then integrated only at the very end, sometimes less robust, more uncertain lines of evidence are given more relative weight than they should. And to be clear, when I talk about a robust database, I'm referring to a high-quality database. And risk of bias is one aspect of study quality. But I note that there are other factors that can impact quality, things like sample size or quality controls, things that can introduce random versus systematic error. And these should also be considered at this stage, not just bias. But even setting this aside, while IRIS has clearly come a long way in terms of risk of bias analysis, it's unclear how these risk of bias analyses are going to be used in future assessments. I took this figure from an EPA presentation last fall, and it's showing the risk of bias analysis where individual studies are looked for specific domains like exposure, outcome assessment, things like that. And then they're ranked as good, adequate, poor, and then individual studies are ranked high, medium, low. And the issue is these rankings definitely have value. They can really give you a sense of the quality of the database. But the problem is when study results are evaluated or reviewed, they're done so kind of on their own, and then this high, medium, low ranking is tacked on. So what happens is that the actual issues that impact study quality get buried in this ranking. And what should be happening is that factors that impact study quality should be considered when those studies are reviewed, when the results are reviewed, so that people can determine the degree of uncertainty associated with those results. And the final issue I want to discuss has to do with strength versus weight of evidence. And I snuck ahead and looked at some of the slides coming up, and it looks like strength of evidence is not defined in the traditional way in which I've seen that sometimes one or even a few positive findings from one or a few studies can be considered sufficient for the basis of a causal conclusion or dose response assessment or the derivation of a toxicity value, the end of this assessment. And whether or not how it's defined, I just want to make sure when this is done, there's all these efforts put into looking into study quality, risk of bias, what does it all mean? And then these things aren't fully considered, and that it's possible that you just have the study or a select group of studies with the most conservative findings being chosen for hazard identification, dose response, or the derivation of toxicity values, regardless of their relative quality to other studies or a full consideration of the totality of evidence. So if a weight of evidence approach is used, endpoints will be identified based on the totality of evidence, with higher quality studies given more weight, and then the studies that are ultimately used for dose response assessment and the toxicity value derivation will truly be reflective of the science. So I'd just like to end, kind of to sum it all up. Obviously, we're going to evaluate all lines of evidence, but evaluate them together, not in parallel. Let each line inform how the others are interpreted. If mode of action data says that positive findings in epidemiology are unlikely, take that into account when interpreting the epidemiology. Make sure study quality isn't just put into a plus, 2 minus, but actually, what does that mean when you're looking at results? And studies themselves and lines of evidence should be weighted based on quality. And finally, use a weight of evidence approach for hazard ID, dose response assessment, and toxicity value derivation. 5 seconds. Thank you.
Okay, thank you. You might have even gotten the bonus 15 seconds. I don't know, but thank you, Julie. Okay, thanks to both our commenters, and I think with that we are back to the next session.